Guys, welcome back to LeetCode with AK. So guys, today we are going to see the LeetCode daily challenge problem. It was categorized as a medium. So I will highly recommend to solve this problem because the problem can be solved by using the one of the famous technique, the recursion and backtracking, and then further optimization can be done by using the dynamic programming. So in this video, actually I'm going to explain this problem, how to solve using the recursion and backtracking technique, and how to optimize this problem using the dynamic programming. So guys, this is really highly recommended because if you want to know more about recursion and backtracking along with the dynamic programming, then definitely this will be one of the best bet. As well as there are some interesting related topic like LIS and LCS. Those are the related topic with this problem statement. So please try to solve LIS, LCS as well as with the LeetCode 712. This will be really more interesting, as well as you will get to know more about the recursion technique along with the dynamic programming. So please stick with me till the end. I'm going to explain this problem statement step by step, as well as you will get some understanding about the recursion technique as well as DP, the memoization technique. Okay, let's move on to this problem statement. The problem is the minimum ASCII daily sum for the two string. Actually, in this problem statement, they will give two string, S1 and S2. So what you have to do, you have to just make the string as a equal. Okay, so for example, if you look at this, let's say if S1 equal to A, okay, and S2 equal to K. So what I said, okay, just make a string as a equal. So if you want to make a string as a equal, so what you have to do, definitely you have to delete K because K is unmatching. Okay, so in order to become both S1 and S2 equal to S2, in that case, so what I am doing, I am just deleting some unmatched character from the S2. So now you will get, if you want to make any string as a equal, any two particular string as a equal, then definitely you have to delete some unmatched characters, right? So what they are trying to say, okay, delete any unmatched character from S1 or either from the S2, just make a string as a equal. Okay, but if you're deleting any string, any particular character, definitely there is some ASCII values associated with that particular character, right? Just you have to return the summation of that ASCII values, deleted ASCII value summation. Okay, so what is the ASCII value for 8? So actually I have a table for ASCII values. So for K equal to 107. Okay, so if you delete K, then definitely the ASCII value for K equal to 107. So for this particular test case, the answer would be 107 because I'm just deleting K only. Okay, so what is the ASCII value for K? 107. Okay, if you look at this example, S1 equal to C, S2 equal to E. In that case, what you have to do, definitely you have to delete S as well as you have to delete T. Why you are deleting S? Why you are deleting T? Because you just want to make both S1 equal to S2. In that case, both my S1 equal to EA and S2 equal to EA. Yeah, my condition, very first condition is getting satisfied because both string get equal. Okay, so what is the result? So what I said, if you're removing any unmatched character from S1 or either from the S2, so what you have to do, you have to return the ASCII value summation. So the ASCII value for S equal to 115. Okay, the ASCII value for T equal to 116. Just add a summation. So answer will be 231. So for this particular input test case, the answer will be 231 because I'm just removing S as well as I'm just removing T. The ASCII value for S and T equal to 231. Okay. So so what they are trying to mean, lowest ASCII sum. So if you look at this example, S1 equal to delete, S2 equal to lead. In that case, okay, I can say, okay, I will delete DE as well as this E. Meanwhile, I will just delete T only. In that case, both my S1 become let, just delete E. So my S1 become let and S2 become let. So both let S1 equal to S2. Okay. So what are all the other possibility? What about other possibility? In the other possibility is just delete DEL as well as delete L only. So it becomes ETE. So no, what's EET as well as it's become also EET. So both are same. Okay. So if you're giving S1 and S2, there might be multiple possibility. You can delete any character from S2, any character from S1. So there might be multiple possibility. So if there is a multiple possibility, so what you have to do? You have to return the lowest ASCII value sum. So suppose if if there is if you're deleting DE, okay, there might be one possibility. In some case, you may delete EL. Okay, so there is a two possibility. One, you are deleting DE. Another, you are deleting EL. So just predict the ASCII sum for DE as well as calculate the ASCII value for EL. Take the minimum out of that. Okay, just return the minimum ASCII value. So what are the unmatched character you are trying to remove from S1 and S2? So this is what the actual problem. So now you got out. Now I hope guys, now you get a clear understanding about what is the problem statement. So the problem statement is you have to make both S1 and S2 make it equal. For that you have to remove some unmatched character. If you are removing unmatched character, definitely you have to add a ASCII value for that one. So if there is a multiple possibility, then you have to return the minimum out of that. Okay. So just take that the very first example. Okay. So S1 C and eat. Okay. So the very first time, okay, I'm just putting a pointer here. I'm just putting a pointer in my S1 as well as I'm putting a pointer in my S2. Okay, the very first time, actually I'm checking whether my first character in S1 as well as my first character in S2 becomes equal or not. No, my first character in S1 as well as my first character in S2, it's not equal. So what you have to do? If that is equal, if there is an unmatched, definitely you have to delete that, because I just want to make some equal make S1 become S2. So in that case, okay, if there is an unmatched character, okay, definitely you have to remove some unmatched characters from S1 as well as from the S2. Okay, so what are the possibilities? Okay, so either I can remove S, either I can remove E. Okay, so what you are going to remove? You are going to remove S or you are going to remove E. You have to try out all the possibility, right? Because as in problem statement they are clearly mentioned, okay, you want to make both S1 equal to S2 and you have to return the lowest ASCII value. In that case, if there is a multiple possibilities, okay, you have to try out all the possibilities to return the minimum ASCII values. Okay, so the very first thing, okay, my S and E it's not matching. Okay, so what you are going to do? Okay, I'm just trying out for all the possibility. Okay, the very first possibility, okay, just remove S. Okay, just remove S. So if you remove S, my S1 becomes EA and S2 become EAT. Okay, so what is the other possibility? Just remove E from S2. Okay, and my S1 becomes SC and my S2 becomes AT. Okay, if you are removing S, definitely you have to add a ASCII value for that one. If you are removing E, definitely you have to ASCII value for E. Okay, so what is the next possibility? So both my, so keep just increment a pointer here. Okay, so both my S1 pointer and S2 pointer becomes equal. In that case, okay, I just want to make S1 equal to S2, but now my pointer in S1 and pointer in S2 becomes equal. In that case, what you have to do? You have to remove. No, definitely no need to remove that, because those two pointers having the same character. So in that case, what you have to do? You have to move forward to find out of the further possibilities, right? So I'm just saying, okay, my S1 pointer and S2 character both are equal. Okay, just I'm moving forward to trying to figuring out the further possibility. Okay, I'm not removing anything, I'm just moving my pointers only, because both my pointers in S1 and S2 becomes equal. So that's why I'm just moving my pointer here. So what about here? Okay, my pointer is here, my pointer is here. Okay, both my pointer is not matching, so I'm just remove S. Okay, if pointer is not matching, definitely you have to try all the possibility to remove a character. So I have two possibility. Either I can remove S from S1 or I can remove A from S2. Okay, just I'm trying exploring all the possibility. In that case, my S2 becomes EA as well as my S1 becomes EA. My S2 becomes only T. Okay, so what about now? What about now? So both my S1 S2 is not matching. Again, I have one more possibility. Okay, just remove. Okay, either E or either T. So okay, if you are removing E, it becomes A. If you are removing T, it becomes EA. Okay. So every time what you have to do, okay, you are doing two things. Okay, if S1 pointer equal to S2 pointer, you are just incrementing. You are just incrementing S1 pointer, S1 and S2 pointer. Okay. If not, so what you are doing, you are trying for the two possibility. What are the two possibility? Just remove from S1 or S2. You are trying for all two possibility. If you are removing any character from S1, then definitely you have to add the ASCII value for that one. So this is a very simple basic pseudocode for this the recursion and backtracking technique. If you look at this recursion tree, so every time, so I'm just following this one. I'm just checking my S1 pointer and S2 pointer become equal or not. If it is equal, please incrementing my pointer. Otherwise, try to explore all the possibility. Okay, please, okay, I'm just trying to writing down the pseudocode here. Okay, so I need a two pointer. Okay, why I need a two pointer? So my very first pointer is pointing S1. So okay, S1 pointer and S2 pointer. If my S1 pointer equal to S2 pointer, simply increment the pointers, increment the both pointer. Otherwise what you have to do, if both are same, if both are not same, if both are not same, S1 PTR not equal to S2 PTR, in that case I have to try out all the possibility and finally I have to return the minimum. Okay, try all the possibility and minimum. Okay, so there is a one base case. These are all the very this is the base case. Okay, I will ask one question to you. So when this operation is going to end, tell me when this operation is going to end. Finally, when my pointer is exceeding the particular string, only then I am going to stop this operation, because if my pointer is exceeding, then what is the next? Already my pointer is just exceeding my string, then definitely there is no more possibility. So the very first, the base condition is, if my both S1 and S2 it becomes exceeding the string length, definitely you have to stop. In some case, okay, my S1 become exceed, but still I have few character in my S2. In that case, definitely what you have to, you have to remove that character, because already my S1 is gone. If there is 1000 character in my S2, please don't worry about that, because already my S1 is totally out of the index. Okay, just remove all the stuff from S2. In some case, S2 is getting exceeded, but S1 still have few character. In that case, you just say, okay, already my S2 is exceeded out of the index. Okay, if there is a 1000 or million character in S1, I'm not going to worry about that. Please simply remove that. So there is two base condition. The first one, if okay, if string length becomes given input string. The another one, remove the remaining character from other strings. Okay, so this is what the very basic the base condition for this recursion. Because if you are going to solve any problem with the recursion and backtracking technique, definitely there should be some base condition. Otherwise the problem can be keep on iterating. If there is no more end, so definitely you will give some time TLE exception. So in order to solve any problem using the recursion and backtracking technique, please try to figure out what is the base condition. So in this problem statement, there are few base conditions. The one of the base condition is like, if index is getting exceeded, sometimes if index is getting exceeded, but still there is few more characters in my S2 or S1. So based on that we have to react. Okay, so the based on this problem statement, actually I just solved this problem using recursion and backtracking technique. So I'll just show the code, how the problems can be solved by using the recursion and backtracking technique. The very first thing, actually I'm just returning one common method, a compute cost. So it's just taking the input for S1, S2 as well as the M and N. M and initially going to be 0 because the very first time, as you can look at this, okay, I'm just starting the index with a 0. Okay, so whenever I'm just taking my S1 index and S2 index becomes 0, I'm just incrementing that. Otherwise, I'm just trying out all the possibility and taking out the minimum. Okay, in this case, okay, I'm just passing my S1 and S2. The value becomes 0 because I'm just starting from the very first character. So I'm just checking my M equal to S1 let. I'm just checking both my pointer is as the last character are just exceeding or not. If it is exceeding, please return 0 because there is no more possibility apart from that. Okay, so if M is exceed, okay, but still if S1 is exit but still there is S2, then definitely you have to remove. If you remove S2, okay, definitely you have to figure out the character code, the ASCII code for the removing value. The same thing applying for both S1 and S1. Then finally, if S1 and the character from the S1 and the character from the S2 both becomes equal, then you have to increment the character, because if there is a both equal, then move on further to try to figure out further possibilities. Otherwise, just try all the possibility and take the minimum out of that. If nothing is matched, okay, still I have few characters in both S1 and S2. Just go forward, try out all the possibility and get the minimum out of that. That would be my final answer. Okay. So in this problem, this would be the base condition. This is where my problem is going to be stopped. Okay. This is my one of the important case to check, to move on further, to check the further, exploring the further possibility. Okay, so now guys, you understand about how to solve this problem using the recursion and backtracking technique, as well as you understand about this the coding part also. So if you have any doubt regarding this coding part, please do your comment. Definitely I love to reply back to each and every one. Okay, so meanwhile I'm ready to share this code. Okay, so what is the time and space complexity? Okay, coming back to this. Okay, I will ask one question to you. Okay, so don't worry about the space complexity, just worry about the time complexity. Okay, so in every step, so what is really I'm trying to do? Tell me what is really I'm trying to do. Please pause this video and please rewind all my input given in this video. Please try to watch that. So if you clearly watch that, then definitely you will get an answer. Okay, so every step I'm trying to exploring all two possibility in every step. Okay, so all two possibility for both S1 and S2. So what is the length? Okay, just imagine. Okay, imagine the size. Just imagine the S1 length equal to M and S2 length equal to N. So in that case, so what you are doing, every step you are trying to exploring the two possibility for both S1 and as well as for the S2 till my S1 pointer and S2 pointer is till reaching the final index. So in that case, I am just exploring the two possibility at every steps till my S1 reaching M and till my S2 reaching N. So the time complexity for this problem is O of 2 to the power of M, and because 2 to the power of M and because 2 to the power of M plus M, 2 to the power of M plus 1, because for every step I am just exploring the two possibility as well as till it's reaching the M as well as N. So the time complexity will be 2 to the power of N. So what about the space complexity? The space complexity also auxiliary space complexity O of 2 to the power of M plus N, because in recursion and backtracking technique, actually I am keep on calling the one function again and again. It will add into the the previously called recursive function, keep on adding into the stack. At one particular state, once my base condition is met, it will be get popped out. At end of the final call, your recursive stack becomes empty. So this space complexity, it's known as auxiliary space complexity, because I'm not creating any array as my asset. I'm just using the recursion call. So because of the recursive stack, okay, I'm just declaring the space complexity also become O of 2 to the power of N, M plus N, because I'm just exploring the 2 to the power of M plus N possibilities. So all m plus n possibility will keep on adding to into my recursive stack because of my recursive stack taking some auxiliary space complexity. Okay, I will ask one question. Okay, how to solve this? How to optimize this problem further? Okay, so I will tell you one simple story. Okay, so let's say you are in source. Okay, someone saying, okay, please travel to path P1 to figure out what is there. Okay, you just travel to the P1 and figure out there is something else. This is what a result what I get when I travel to the path 1. Okay, again someone saying, okay, travel to P2 path 2. Okay, figure out what is there in path 2. Okay, and again you're traveling to the path 2, figuring out all the possibility. Okay, and third person is coming into picture. He will tell, he will again insist you, please travel to P1 and find out all the possibility. So in that case, I will ask one question. You already traveled in P1 path 1, right? If someone is saying go and travel in path 1, so what you will do? Okay, already I traveled in path 1, I know what is there in path 1, what is the result will be in path 1, so I no need to travel. So whenever you are saying travel to path 1 and path 2, since I had a experience with the path 1 and path 2, I know what is there. Okay, in that case, so how we are telling I just traveled path 1 and path 2 previously, because you have a track in your memory, right? So because of that track, okay, you are saying, okay, already I traveled path 1 and path 2, please don't insist me to travel because I know what is result there. So what do you know, if you are doing the problem again and again, if you have the track for that, okay, definitely you will tell to the person, okay, I have a track for that, I have a result for that, okay, I know what is that. Okay, so if you want to figure out a repetitive task, so what you have to do, you need some track. Okay, you need some track in your hand. That track should tell already the path is being traveled, as well as the track should contain the result of that path. So only then, whenever someone saying, okay, you will tell, okay, I already traveled, this is what the result. Okay, now I will ask one question to you. Okay, so whenever there is any problem can be solved by using recursion and backtracking technique, please ask one question to yourself. Okay, the problem can be solved. Okay, there is a huge problem in that beginning. You're just cutting the problem into smaller sub problem, and finally you met the problems, you get a solution for the deepermost smaller problem, and then you're backtracking each level, and finally you're figuring out that you're just calculating the final result. Okay, so every time whenever you are finding out a possibility for every sub problem, okay, there is a sub problem. Okay, is there anywhere repetitive sub problem? If there is any repetitive sub problem, then definitely the problem can be solved by using dynamic programming. Okay, as you can see here, the very first time I'm just removing S, I'm removing E, and then again you can see I'm just removing S. Okay, already I already removed S in one of the possibility. Okay, already removed S in one of the possibility. Again I am removing S. Meanwhile, see, as you can see, I am removing E here and removing E here. So which means there is repetitive subproblem. There is a subproblem. Okay, I accept that, but there is a repetitive subproblem. If there is a repetitive subproblem, how we are going to insist a program to tell? Okay, already I solved this. How to tell this? Definitely you need a track, right? You need a track in your hand. You should insist, okay, this possibility I already explored, this is the result of that. Then in that case, definitely you can able to restrict that repetitive iterating after repetitive subtasks, right? So that is what we are going to do. If there is any other problem can be solved by using dynamic recursion and backtracking technique, as well as there is some repetitive subtask, definitely the problem can be solved by using dynamic programming. The very simple dynamic programming approach is memoization, I mean bottom up approach. So in that case, so as you can see, okay, I just solved this problem using recursion and backtracking technique, but what I did, I just simply creating one DP array. Okay, whenever a DP array, I'm just initializing my DP array equal to -1. So which means if my particular DP array is -1, which means I didn't explore the possibilities. Okay, so whenever I'm trying to exploring any possibility, I'm just storing that possibility into my DP array, because I just want to know the track in my hand. Because of that, I'm just storing my result into my DP array. So whenever the program is kickstarting or exploring the further possibility, I'm just checking, okay, my DP is already, this particular possibility is being explored or not. If it is explored, please return the value, because you already explored, you have a track in your hand. So why should you move forward to explore further deep down? Okay, if not, just move forward to explore. So this is what actual the bottom up approach, the memoization technique. So there is another approach called the top down iterative approach. So in that approach, there is no more recursive call. So if there is a using the recursion backtracking technique, definitely you can solve this, you can easily solve the problem using the bottom up approach, I mean the memoization approach. So in that approach, just create one DP array and keep a track of the result on every possibility. Before exploring anything, just check, okay, the possibility is being explored or not. If it is explored, just return the value from the DP array. So this is what the actual, the bottom up approach to solve this problem. As you can see, I am just saving the all the possibility in my DP array. Okay, so what is the time and space complexity for this problem? Okay, so as I said, okay, so again you are exploring two more possibility on each step, but this time you totally different. Okay, why you are totally different? Because you, even though you are exploring two possibility, but you are not doing repetitive tasks again and again. So in that case, I will ask one question to you: how much time your program will keep on exploring the possibility? Definitely your program will keep on exploring the possibility till n cross n, because I just want to figure out all the possibility from size of m, I mean s1, as well as the size of n, I mean s2. So definitely your DP program will keep on iterating to figure out the possibility for m cross n. So time complexity would be, your DP problem would be O of m cross n. What about the space complexity? Space complexity really very simple, because I'm creating one array. Okay, then as well as I'm using calling the recursive code again and again, it takes some space in auxiliary time space complexity. As well, apart from that, I'm just creating one DP array. It's a size of m cross n. So my final bottom up approach, the time complexity would be O of m cross n, and the space complexity would be O of m cross n. Okay, so guys, now we understand about how to solve this problem using recursion and backtracking technique, as well as how you further optimize the problem using the dynamic programming. Okay guys, so I will share this problem, the problem statement along with the code in my description. Please go through that. If you have any doubts, anything, please ping me in comment section. Definitely I will love to reply you back. So I will meet you on tomorrow with different interesting problem. Thank you guys. Please keep on subscribing to support me more.